So welcome back. We have Dr. Saket Dubey with us. He's been very kind to allow us to, or to also demo for us his drone, which is a DJI Mavic 3. So Dr. or 3 or 4? 3, yeah. And Dr. Saket is an expert in remote sensing and water resources, and he has extensive experience in some of the things that we've been discussing. So this is a map that Dr. Saket created of the campus. It's a very beautiful map of a beautiful campus, and you can see the resolution here is 31,000 pixels by 18,000 pixels. So it's a very large orthomosaic. I'm not too familiar, so I don't know where we are in the campus. To the right or to the left?
This one, yeah. So you could able to see there are like 3 flower type of
here.
So we are in one number, yeah. So first one.
That one. First one. I don't know.
Yes, yeah, you're right. This one. Below that. You can see the pattern, right? It's like a flower.
So the drone itself has a few different automated flight modes. Now we want to be super cautious, and so Dr. Saket also shared a screen recording of what the drone controller looks like, and you can see the modes that are available in this drone. So Dr. Saket mentioned that the drone costs about 4.4 lakhs, and so there's a waypoint route, and there you will specify specific points that you want to be using. There's area route, and so this I think functions on a flat plane. Is that right? So you specify the plane, and then you specify the perimeter, and then it does the hatch in both directions. There's a linear route. I'm assuming you can have a fixed set of points and it does a line. There's a slope route, and then there's a geometric route. So for doing buildings, either waypoint, area, or geometric route would be options to consider depending on what your objective is. Like if you're trying to do detailed inspections of the facade, then maybe you want to do a geometric route. But if you want to create just a digital elevation model or just get the overall geometry, then the area route would be a good option. The area route is much safer. And why is that? Well, it's safer from a standpoint of the drone not crashing because you're flying above everything, and so you can safely know that you're not going to hit any obstacles. You just need to make sure that you're flying up in an open area where there's no chance of hitting anything, and you're flying back down. So this drone does have some obstacle avoidance, but we haven't practiced the geometric route, so we're going to do the area route today. And so for the area route, there are a few parameters that we'd have to decide. First one being the height above the structure. And so at a minimum, we need to know how tall the building is. So any estimates for how tall this building is? How many floors? 3+2, and there's anything on top? Yeah, so it's about yeah, to be on the safe side, maybe that's a bit high, but so we can probably fly at yeah. So if we're doing the overall structure, then we can fly even higher than that because we will still get a reasonable model. And then we need to decide the angle at which the gimbal is going to be for the different hatches. And I would recommend having an oblique view so we can see some parts of the elevation as well. So, so with the drone, what are the angles that are possible? You can go. Yeah, because we're looking down, so it's fine. So maybe maybe we can do 60 degrees, and then we need to set the speed, and we need to set the overlap. So for the overlap, we can have 80% overlap, and then for the speed, because so if the drone is flying higher, then you can be going faster, but if it's flying lower, then the rate of change is going to be higher with respect to the top of the building. And so if you're flying too fast, it's going to cause artifacts. So do you have a recommendation for a good speed? You would, that's very fast. So I think we can probably do, we can fly lower and do, you know, probably, you know, 15 kilometers per hour. And so that would be, I would say probably 50 meters or 40 meters is okay as a height. Yeah, and then we can go to, if we can find another building which is far away, then we can, and if we still have battery left, and if Dr. Saket and I both think it's a reasonable idea, then we can try to do the other mode as well. But let's try the area mode first. And for that, I think it doesn't matter so much where we do it. I do have a rule of thumb for how far you need to be for to be able to measure to be able to get a good reconstruction. So depending on what you need, if you're trying to get good measurements, right? We looked at how to determine your distance to surface based on the crack resolution, for example, right? But here, say you're trying to get good measurements of the elevation, then it's a different computation. The rule of thumb is if you want whatever your ground sampling distance is, your model accuracy will be approximately 3 times that. So if you have a GST of 1 millimeter, then your GST will be approximately 3 millimeters. Sorry, if you want a GST 1 millimeter, then your model accuracy will be approximately 3 millimeters. And so to determine the height, we need to be flying at, if we set the resolution we want our measurements, then we can find the GST. So say, for example, we want the model to have a resolution or accuracy of at least 4 millimeters, then we can set a GST of 12. And then we need to look at the manufacturer's table to see what the distance to surface needs to be for 12 millimeters. So let's see if, do you know if DJI has those tables? We can compute it. Do you know what camera it has? 20 millimeters, 20 megapixels. Okay. DJI Mavic 3 Enterprise, GSD distance to surface. I don't know if this exists. I'm Googling this for the first time. They're giving us a formula, we know that, but we have to do the math. Okay, it may take some time to find all the parameters that we need. Let's try to do analogy. So I have the formula actually for Skydio extend, not on this one, but so I think they haven't published the formula yet, but we got it from the manufacturer, so I know that it's correct. So for 1.27 meters, we can do 15.7 meters. So for 12 millimeters, we can do 10 times that, so 175 meters. But that's with the extend. This is the field of view of the extend, and that's the resolution. So this is 7 times 9, which is 64 megapixels, and the DJI is 20. So if we divide by about 3.2, then you get 150 divided by 3.2. Assuming it's the same field of view, that would be about about 50 meters or so. So we can fly at 50 meters and get a accuracy of 10. So according to this Skydio website, what they claim, and we haven't verified this, but what they claim is if we get a GSD of 12, then we can get an accuracy of about 36. So 0.36, 3.6 centimeters. Yeah, but again, that's with that camera and drone, so it may vary. But I think 50 meters is a reasonable height because it's above the building, it's sufficiently above the top, and it gives us a reasonable model resolution. So those are the computations you have to make before you go out in the field. Okay. Any questions about that? All right. So in that case, I think we can start to head out. And is there in the okay? So let's play the video. This one, right? Oh, I'm not sharing my screen. Did it stop now or? Yes. Say that again. So you want to make sure that you're collecting data at the accuracy that you need. It depends on what your goal is, but if your objective is to create a model, then you want to determine how accurate you want that model measurements to be. Say you have to determine the clearance under a bridge. You need the elevation under the bridge deck to be accurate so that you can decide what is the maximum height of the truck that can go under that bridge. So say you want to be accurate up to 1 centimeter so that you can prescribe what is the maximum height of the truck that can go under the bridge. Then you need to compute what is the distance you need to be from the bridge to be able to map that out. And a rule of thumb in photogrammetry is 3 times the GST. So you compute the GST, you compute the accuracy, then you compute the GST, and then you can use the GST to compute the distance to surface based on your particular camera. Okay. Of what unit? Of centimeters, or? Yeah, but that is for the, is that model resolution, or is that the ground sampling? Yeah, but I'm saying the model resolution will be 1/3 of that, or 3 times that, into 3. Ground sampling distance is 1.5, so the model resolution will be 4.5. Yeah. So I think that's consistent with, I mean, I calculated 3.6, 4.5. So let me, Dr. Dubey shared this video, and so you can see that he's setting the perimeter points for the area that is going to be scanned, and then uses the aircraft model. This is the MIT M3E Enterprise, and setting the GST, so you can just set that here. You don't have to worry about doing the calculation, I guess. Just set it there. So you set it to, yeah. So that's good, right? You can just do it in the control. You knew that when I was explaining all of this. And you can set the speed. We can slow it down because we're going to be a little lower. Set the angle. That's the angle of the hatch. But you also have to set the gimbal angle. But you can set it manually, I guess, before starting, and it stays at that. You have the overlap ratios. And you can choose the interval at which you're taking photographs. But I think that's automatically set when you choose the overlap. And I think that's it. Okay. So easy peasy. Questions? Okay. Then I think we can go outside and then witness this.